Functions of the form y equals f of mod x. Note the position of the modulus here. We've been dealing with y equals the modulus of f of x. Now we're going to be looking at function of mod x. This is basically repeating the values of positive x on the negative side. So throughout the graph, and is simple to draw. Start by drawing the graph of y equals f of x. Erase the graph on the left-hand side of the y-axis. Using the y-axis as a line of symmetry, reflect the graph from the right of the y-axis onto the left. Clearly, once you have done this process, you will see that there is no need to draw the part of y equals f of x for negative values of x, i.e. those that are to the left of the y-axis. Just draw the section for positive values of x and reflect it. Now, why does this work? First of all, let's consider y equals mod f of x. If we have a table, x f of x mod f of x, and we put in some values of x, say -3, -2, -1, 0, 1, 2, 3, then we know that we're going to get f of -3, f of -2, f of -1, and so on. And when we come to this line, every time one of these is negative, we just take the positive value of it. And that's why we get the bounce up from the x-axis. We're now dealing with f of mod x. So if we're doing a table of values, we could have x mod x and f of mod x. Let's say we have -3, -2, -1, 0, 1, 2, and 3. The modulus of x is 3, 2, 1, 0, 1, 2, 3. So when we take the function of mod x, here we get f of 3, then we get f of 2, then we get f of 1, f of 0, f of 1, f of 2, and f of 3. You can see the symmetry about the y-axis. The point corresponding to this is plotted at -1, f of 1. So the function for negative values doesn't exist as such, it's just a reflection of what's on this side. Be careful, occasionally I've seen questions which are y equals f of negative of mod x, and then it reflects the other way. We take what's on the left and reflect it onto the right.